Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this topic, we are going to discuss about CAN bus protocol. CAN means Control Area Network. For this topic, you can refer the textbook is Introduction to Embedded System by Shibu KV or CAN datasheet. CAN data. I can prefer data sheets for always getting the real-time information. CAN means Control Area Network. It is one of the communication protocol used in the embedded systems. It is a synchronous serial wired communication bus. It is used in the automobile field since it provides more security by adding cyclic redundancy bits. It is always preferred. It is widely popular. With maximum data rate, it will transfer the data. We will check one by one. Control Area Network. It is a high integrity serial data communication bus for real-time applications. Means automobile applications. Automobile. Example, in between anti-lock braking system, airbags in the car, and so on. Engine control, ignition control, integrated parking brake. I worked on integrated parking brake like that. Next, it is designed for maximum performance and reliability. Okay. Next, it operates at data rates up to 1 megabits per second. It transfers the data with baud rate of 1 megabits per second up to 40 meters data length. It is an international standard. It follows ISO 11898 to provide the security. It supports multi-master bus access. Means any node, here node in the sense some features, either airbags, either anti-lock braking systems, either engine control, either ignition control, either wiper control, either entertainment, either GPS, like that, any feature. So each feature is one embedded control unit, like is electronic control unit or embedded control module, ECM or ECU. So any node can wants to share the data. It acts as a master. The device which wants to share the data, that device is called master. The device which requires the data, that device called slave. So here, if you look at a car, it contains more electronic control modules or electronic control units. Each node acts as a master whenever it wants to share the data. Next, CAN bus broadcast the messages to the particular devices, broadcast the information. Based on the message priority, it will transmit the data. It transmits the data up to the size of 0 to 8 bytes in a single frame at a time the CAN bus shares from 0 bytes to 8 bytes based on the requirement. So CAN bus provides excellent error detection. If any malfunction occurred during the transmission of the data, it will find out and rectify that one. And it can have fault confinement. So in CAN bus, various frames are there. Mesh data frame, remote frame, error frame, like that. Whenever we want to get the data, at that time we are sending the remote frame. After getting the request, the CAN node transmit the data frame. During transmission, if any error occur, at that time error frame will be generated. Okay. First we will discuss remote frame. First I want some data from the another node. At that time I am sending the remote frame. In this remote frame, the frame contains by default it is an ideal condition. Means that value is bit value 1. Whenever the framework is started, the bit value is 0. In the communication bus, we are transmitting zeros and ones. The value is 1 means the continuously means that is bus is in ideal condition. Whenever that value becomes from 1 to 0, that indicating it's start of the frame. SYF means start of the frame. Next 11 bits indicating ID. Arbitration field means here destination to from which device I want data. During manufacturing itself, we are assigning particular ID to each electronic control module. Electronic control module means some application, airbags, ABS, like that. Okay. So this 11 bits may be either zeros and ones. That is created during manufacturing itself. Next, it contains control field. So which type of operation wants to perform, either read operation or write operation. Either 29-bit frame or 11-bit ID. Next, it contains cyclic redundancy field. So to provide the security to the content, we are adding cyclic redundancy bits. That size is 16 bits. This control bit is 4 bits. After the cyclic redundancy bits, it contains acknowledgement bit. If successfully transmission, it will get 1. Then it contains 3 ones that indicating frame is ended. Next, intermediate frame status. Next, bus is in ideal condition. So this value is 1. Bus is in ideal condition means the bit value is 1. Like this, the device which send the request to the desired device from which it wants some data. Either sensor, current room temperature, current intruder information, current pressure information, current object information, like that. Engine speed, engine temperature, whatever the parameter information it wants. After sending the request, the desired device send the information, that is data frame. Initially, that is an ideal condition. At that time, that value is 1. Whenever the value 1 becomes 0, that indicating the frame is started. Next 11 bit indicating arbitration field means destination ID. To which device it wants to share the data. Again, it contains 4 bits. It indicating either read operation or write operation is going on. Next, 0 to 64 bits that indicating information. So 27 degrees, either some object is there, either some accident occurs, like that. The information that is available here. That range is 0 to 64 bits information. Next, it contains 16-bit cyclic redundancy check. that provides the security bits to provide the security to the information, to avoid the unauthorized access. Next, it contains acknowledgement field. So the frame is successfully transmitted or not. Next, it contains end of the frame. That value is 3 ones. Next, it contains intermediate frame status. Next, it contains bus ideal. That value is like this. We are transmitting the data frame. Next, error frame. If any error occurred during the transmission of the information, that error frame is generated. This error frame contains 6 bits error flag. So total 14 to 20 bits. This error frame size is 14 to 20 bits. So 8 bits error delimiter. Next, retransmit the information. We will check one by one in detail. Okay. This is the data frame. CAN data frame. So initially, bus is in ideal condition. That value is 1. Whenever that value becomes 0, that indicating start of the frame. Next, 11 bits indicating destination ID, to which device it wants to send the data. Next, 1 bit indicating remote transmission request. Next, 6 bits indicating control field. Next, 0 to 64 bits indicating information. Next, 15 bits indicating cyclic redundancy code. 1 bit is interface gap and that value is 1. And next acknowledgement bit, if it is successfully transmitted, value is 1. Acknowledgement again 1 more bit. Next, end of the frame, it is 7 bits. Next, intermediate frame status is 3 bits. Next, bus is in ideal condition. This means its value is 1. Here, destination ID either 11 bit or 29 bit. Okay. So initially, in case of 12 bit, the difference is here 11 bit ID or 11 bit plus 18 bits, totally 29 bit ID. Okay. So this is error state indication. So in the initial position, errors are 0. Whenever error any occurred, this count will be started. Whenever error count is greater than 20, greater than 27, that is REC, error passive. Whenever it is reaching the more than 128, it goes to bus off condition. So see here, normal mode, request in 128 mode, 128 occurrences of 11 consecutive, retransmit state. So it checks some initial error count is 0. Whenever the error count reaches the limit, the bus stop the transmission and check that errors, clear that errors. So, in the communication protocol bus in CAN wire, different nodes are there in the coming to any embedded system. It contains more than one applications. Each application wants to send the data or receive the data. At that time, this is serial communication, means at a time only 1 bit will be transmitted. So, which bit needs to be transmitted? That depends on the priority. So, the priority will be checking based on bus arbitration. So, which message needs to be transmitting on the protocol bus in the wire, CAN bus wire, CAN cable. First, which one needs to be transmitted? So, coming to the LSB to MSB, so which bit is having high value? Suppose 0, 0. Just see here. 0, 1 to 9 means total 10, total 11, 0 to 10 means 11 bit ID. Total 11 bits ID is there. Here that value is 1, here value is 1, here value is 1, here value is 1. Next, first bit 1, 1, here 0. So we can check the bit values one by one. So first bit is coming as highest value, that is highest priority. So after transmitting the data, each bus contains message buffer. If the buffer is full means it does not receive the informations. So we need to check the information is received properly or not. Okay. So whenever buffer is full, the data is not received. So again retransmit the information. Like this, CAN bus share the information from one embedded system to another embedded system using CAN frame. To verify this one, we can use CAN OE IDE tool. CAN OE IDE tool. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.